Hello everybody, welcome back to online lessons. Here we go, is section 7.4. We're getting down through the nitty gritty here. 7.4 is all about solving oblique triangles. And what is an oblique triangle? Oblique triangle is any triangle that is not a right angle triangle. Now in the next two sections, you're going to learn a couple advantageous techniques, the sine law and the cosine law. But in this case, I want to show you the ability to problem solve and finagle your way through solving a non-right angle triangle using right angle triangle concepts by constructing what you need. Now, before we get into that, just going to go over different types of triangles that we look at. Now, obviously, this should jump out. If you know two angles of a triangle, you can solve for the third because angles in a triangle add up to 180 degrees, so that's handy. But so this first triangle is either called an ASA triangle or an AAS triangle. So it's ASA because you have an angle and a side sandwiched in between another angle. So it's A, right? Angle, side, angle. Whereas this next one on the right, you have an AAS. So if you go around, you have an angle, angle, side. So that's type number one. Now the next two would be an angle sandwiched in between two sides. So you have a side, angle, side, which is a SAS triangle. See that here. It's not a highlighter. There we go. And obviously not the color I want, but hey, deal with it. So then we have a three-sided triangle, which is just, as you could probably imagine, it's called a SSS, side, side, side triangle. You have all three sides. And then the last one, which is the most finicky, and it's almost kind of fitting, it's an ASS, or the ass triangle. This thing is a pain in the ass. That's why it's good, helps you remember, and you're going to see that more in section 7.5, the sine law. For now, we're not going to worry about this ambiguous case. You will see that in the next section. But it's only something you need to test for, only something you need to consider when you're dealing with this pain in the ass triangle. Okay, so it is fittingly named. So let's just do a few examples of how do we solve oblique triangles without knowing these sine and cosine laws yet. Now, obviously, it helps to be able to draw your triangle, and that can sometimes be the hardest part. So remember that the side name is always across from the angle. So like side A, like little a, is across from angle A. Customarily, you'll draw angle A in the bottom left-hand corner, but you definitely don't have to do that. So if you're drawing your triangle and it doesn't quite look right, try and reorient it. Try and draw it again. Try your best to draw your triangle as clearly as possible. Now, in this case, we know a little bit of stuff. We know that angle A is 30 degrees. Now, you also want to try and draw your triangle as realistic as possible. So if I had a straight line here along the bottom, 30 degrees would be about there, right? And then I know that side, and this is angle A. So I'm going to give this A. We know that side B is 10, and we know that side C is 8. Now, one thing to notice is B is bigger than C, which means the angle of B is bigger than the angle of C. We don't really worry about that right now because we don't know either of those angles, but we can calculate. It's just a way of making sure you calculate it right. So what I'm going to do is I'm actually going to connect those, and there's my triangle. All right, so what I have is I have angle A, and I know it's 30 degrees. And I'm going to just go clockwise with my labeling. So I'm going to say this is B up here, and this is C. What I know is that side B is 10, and I know that side C is 8. So what I don't know is side A, I don't know angle B, and I don't know angle C. So that's what I'm trying to find. Now the thing is right now is you have no help here. You don't know how to do this, right? You don't have a right angle triangle. You have no formula or concept that you can use. So what are you going to do? Well, you can create a right angle triangle. Now, few things you'll notice in the written notes, not the video notes, is that when you're calculating a trig ratio, okay, 3 decimal places. So like 0.772. If you round too early, it's going to throw off your angles by like degree or two. So 3 decimals in a trig ratio is good. Now also, what kind of triangle is this? What do we have, right? We have a side, an angle, and a side. So this is an S, not that it matters, but nice to be able to identify. This is an SAS triangle. Okay, so what are we going to do here? Well, if you don't have a right angle, make a right angle. And you can make a right angle by dropping a perpendicular from any vertex. Now, vertex is like point A, right? Vertex, vertex, vertex. Now, looking at your triangle the way it's drawn, yeah, you could drop one from A, but what's the point? Drop it from B. So you're going to drop a vertical line that's perpendicular to AC, which means it creates a right angle. Okay, so that now you'll notice, sorry, I'm just messing with the size. There we go. You'll notice that when you drop a perpendicular, you can call it height. Now you have a right angle triangle. And you have an angle, and you have an opposite and a hypotenuse. So angle, opposite, hypotenuse. So we can solve for h. Now, in order to solve for a, first we need to solve for h. Okay, we can solve for h by going sine of 30 degrees is equal to h over 8. And then h is equal to sine 30 degrees times 8, right? So do that calculation, you end up with h equals 4. So what we can do is we can erase the h and we can write, okay, well, I actually know that that is now of length 4. So what does that do? How does that help us out? Well, we're getting a bit closer because now what we can do is we have this whole distance of 10, and I'm going to erase this side angle side to not get in the way, because you're going to see I'm going to draw all over this thing. So we have this entire distance here is 10. But I'm going to break it into chunks at here, and I'm going to add an extra letter. I'm going to put a D there. So this A to D, I'm going to call length D, and this D to C, I'm going to call length E. And you know that D plus E equals 10. Okay? Great. You're going to see why that's helpful. Because now that we have h equal to 4, we can solve for D by using Pythagorean Theorem, because I'm going to circle them in green. You have hypotenuse, you have one side, you have another side, right? So D squared is equal to 8 squared minus 4 squared. So D squared equals 64 minus 16. D squared equals 48. So that means D is equal to the square root of 48, which we can simplify down to 6.928. And you'll see I left 3 decimal points. You could also have done that using cosine. You could have gone cos of 30 degrees is equal to adjacent D over 8 and solved as well. You would have got the same answer, so either way is fine. Now that you have D, you can solve for E. And you can solve for E quite easily because you know, partition here, you know that D plus E equals 10, right? So, and you know D now. So that means E is equal to 10 minus D, which is 6.928. So E is equal to 3.072. Now that's helpful because now go back up to the drawing. If you look at it in blue, you now know this and you know this. So you can solve for A using the Pythagorean Theorem because A squared is equal to H squared plus E squared. So A squared equals 16 plus 3.072 squared. 16 was from the 4 squared. I just knew that one. So A squared is the sum of those. Square root that, you get a, and I'll just simplify it. A equals 5.04. So boom, that's part A done. We just solved for a, 5.04. And the good news is now, since you have, if we consider this triangle, you have one side, you have another side. So you got this side, you got this side. You can solve for C by using some right angle triangle work. So I'll kind of redraw the drawing right here. Right, that little triangle kind of looked like this. This was the letter E. This was A, and this was H. And we had solved for each of those, right? We'd solved that H was equal to 4. We solved that E was equal to 3.072, and then we just solved for A at 5.04. And now we're looking for this angle, which was angle C. You can use any trig ratio you want because you have all of the pieces of information. In this case, I'm going to use 10, so I'm going to use 10 of angle C is equal to opposite over adjacent. So tan inverse of that fraction is equal to the angle. So angle C, now here's A we solved for. Angle C is equal to 52.5 degrees. And now angle B is really easy to find because we know that angle A was 30. Angle C is 52.5. So that means angle B is 180 minus those. And it comes out at 97.5 degrees. So a lot happened there. We solved for angle C, we solved for angle B, we solved for side A. We used Pythagorean Theorem a lot, and we used our right angle trig a lot by manipulating the given triangle. So there's quite a bit going on, but it's all stuff you've learned before. So it's not a matter of anything new coming at you, it's just a matter of looking at something in maybe a different light. Okay, so let's move on to example 2. Again, here we go. We're going to draw. I'm going to start. Here we have 3 sides. So we're given a side triangle. You have angle A in the bottom corner. That's where I'm going to start at bottom just because I'm used to doing that. And then you got B and C. You can see that C is the biggest side. So you're going to want C to look like the biggest side in your drawing. So if we were to draw this, we don't know any of the angles. So I'm just going to kind of freehand this thing. And it's going to look, now if only that looked perfect, there, right? Now, some of you might be like, Herlar, that looks like equilateral. It's not, or isosceles, it's not unless it's marked so. So what I'm going to do now is I'm going to mark this thing with some, I'm going to say, okay, well, that's A. Now, last time I said this was B, but there's a problem there because C is the biggest side. And if you look at this drawing, the biggest side is on the bottom. So this has to be C, and that's going to be 12. And this is going to be 8, and this is going to be 10. That kind of looks as right as possible, so it's fine. It's a good place to start. Remember, it's your drawing, so do with it what you will. Now, in this case, we're going to do a very similar scenario for finding angles. You don't have any trick to find anything right now, so boom, drop yourself a perpendicular. Now, herein you're going to notice this is going to take a little bit of extra work, okay, because you don't know enough information. You don't have an angle. All you have are sides. So if you have this scenario, right, it's the same thing again. That equals 12. Now, if you were to cut this off, let's just call this D, and you said, okay, well, let's make that equal to X from A to D. Well, then what's D to B? I don't know. Well, you do know. You just don't know with respect to anything other than X. That is 12 minus X, right? Because it's the whole distance minus the distance from A to D. Now that you may be like, well, that doesn't really help, but it will. And now this is your height. So off the bat, we're going to have to be a little bit, tricky is the wrong word. Let's just say mathematically fluent, all right? Because what do you know? You know that x squared plus h squared equals 10 squared. And you also know that 12 minus x, which is a number, right, squared, plus h squared equals 8 squared. Now something interesting is happening here. You have, rewrite this to h squared equals 10 squared minus x squared. And then you have h squared is equal to 8 squared minus 12 minus x all squared. So you have two statements that are equal to the same thing. Since they're both equal to h squared, you can set them equal to one another. So I'm going to say 10 squared is 100, so I'm going to say 100 minus x squared is equal to 8 squared is 64, and then minus 12 minus x squared. So now we have to do a little bit of work. We got to factor this thing out. Remember, this is 12 minus x times 12 minus x. So I'm going to shorthand that. I'm not going to write the whole thing out. I'm just going to do it. The 12 times 12, and keep it in brackets so you don't forget to subtract everything. 12 times 12, so FOIL is 144. The 12x and the 12x are going to give me minus 24x, and then the negative x times the negative x gives me plus x squared. So I've foiled that out, and this is why I said keep the brackets, because you need to multiply that in. So now you have 100 minus x squared equals 64 minus 144 plus 24x minus x squared. Now you have an x squared on both sides. Those are going to cancel out. If you get all the non-x's together and the x's together, you end up with, let's get all the non-x to the left. So you have 100 minus 64 plus 144 equals 24x, which is 180 equals 24x. So x is equal to 7.5. So now you know that this, I'll do it in blue so we can see what I'm filling in, 7.5. And you know that the 12 minus x is going to be 12 minus 7.5, right? And 12 minus 7.5 is 4.5. So you know that that is 4.5. So you've got some info filled in on your triangle. And the thing now is you have two sides of two things, right? You have, again, I'll change colors so you can see what I'm dealing with. You have a side, and you have a side and a side of the two, like this triangle here and this triangle here, if you look at them as two separate triangles, which allows you to be able to solve for angle A and to solve for angle B using cosine. Right? So let's do angle A. So cos angle A is equal to adjacent, what we just found out, over my hypotenuse, which means that angle A is equal to the inverse cos of that. So angle A is 41.4 degrees. I'll do the same for angle B, except just change my numbers. Cos B is equal to 4.5 over 8. So angle B is equal to the inverse cosine of that. So angle B is equal to 55.8. And now you're basically there because you have 2 of 3, right? So that means angle C is equal to 180 minus 41.4 minus 55.8. Angle C is equal to, and you should expect it to be the biggest because it's the biggest side length. Biggest angle corresponds to the biggest side, and you get your 3 angles. So again, a bit of work, mostly Pythagorean theorem, but this piece here of setting the thing equal to itself, or equal to one another because they're equal to the same thing, helps you solve for multiple, when you have multiple variables in an equation. So that's 2 examples of acute triangles, or sorry, not acute. Well, yeah, sorry, acute, each angle less than 90 degrees. This next one we're going to look at where one angle is obtuse. It's a little bit of a different ballgame. So you can see right off the bat here, example 3, angle A is 110 degrees. So, okay, well, what does that look like to me? Well, it's more than 90, so I'm going to draw it like this. There's my triangle. Okay, and this time I'm going to say, well, I'm calling this angle A. I know it's 110 degrees. which means this is side A. Right away, I should be able to tell myself that's definitely going to be the biggest side because it's the biggest angle. Okay, angle B is 20, so just look at your drawing. Which of these vertices, right, here and here, looks like a smaller angle? Ah, this one does. So I'm going to call that angle B. I know it's 20 degrees because 20 is pretty small. Now you know two of the three angles, right? So how do you get angle C? Well, it's just 180 minus 20 minus 110. So that's angle C is equal to 50. So boom, I know that that's 50 degrees. So just like that, you've solved for angle C. So that's part A of this question, right? Solve for angle C. Now you need to solve for side B, and you need to solve for side, you know that that's 10. You need to solve for side A. Now in this case, dropping a perpendicular from the obtuse angle, so from here, right? It's going to be a lot more work than it needs to be. There's another trick, I hate the word trick. There's another scenario you can use here, okay? And that is to drop the perpendicular at the outer portion in line with this, right? Still perpendicular. And what you've done is you've created this perpendicular triangle in the corner. And right off the bat, you might be thinking, well, that doesn't really help at all. Well, it kind of does, because this is a straight line. So we know that this has to be 180 minus 110, so that's 70 degrees. And if that's 70 and this is 90 in the corner, well, we already know that that's going to be 90 and 70 is 160, right? So that's going to be 20. We don't need that 20, but we'll put it there anyways. Now we still have, we'll call that height. We're going to call this x. We still need that to solve for b. Now I'm going to erase the b that I've written in here just because it kind of looks, and I'm going to put it here. Okay, so now how do I find b? Well, in order to find b, what can I use to get there? Right, like looking at it, do I know x? Nope. Do I know h? Nope. Do I know b? No. So, how are you going to go about doing this? Right, well, we need either x or h. Now, if we look at tan of 70 degrees, I have both my unknowns, x over h, right? So that means h is equal to x times tan 70 degrees. Why did I do that? Well, because where else do I have x, right? Where I can solve for h. Well, look at this. You have a triangle here. Right? You've created this massive right angle triangle where you have here that tan of 20 is equal to h over this distance, which is x plus 10. Now that might seem like, okay, well, that's weird, but that means it's x plus 10 times tan 20 equals h. So now again, you have two equations equal to the same thing. So what can you do? You can set them equal to one another, right? So how do we go about that now? Well, we have x tan 70 is equal to x plus 10 tan 20. Now, remember that tan with a number, like tan 70, tan 20, those are numbers, right? Those are going to be decimal numbers, but don't convert them yet. It's just you end up having to carry around a lot of extra decimal points. Just keep them as their numbers until you're ready to calculate. Now, this tan 20 is an item, right? This is one number. So think about it that way. It's got a water bomb into there and into there. So x tan 70 is equal to x times tan 20 plus 10 times tan 20. Now the idea here is we got to get our x's together. So I have x tan 70, and then I'm going to subtract x tan 20 from both sides, right? You're going to subtract it from there, and then I subtract it from there. And then I'm left with this 10 times tan 20. The reason I did that is because now I have a common factor in those two terms, which is the x, and I can factor it out. So x times tan 70 minus tan 20, which is a number. So now you have two scenarios where you have a number and you can isolate your variables. So x is equal to 10 tan 20 over tan 70 minus tan 20. Now remember, calculator in degree mode or it'll throw everything off. Throw that calculation into your equation, right? 10 times tan 20, boom, divide, simplify. Make sure you are using your calculator properly. If you get a different answer here, you're using your calculator wrong. X is equal to 1.53. Get really fluent at being able to use your calculator with trig functions. That's the hardest part. Okay, so now we've solved for the x value here, which means we can now solve for the b value here. And once we have b, then we can figure out how to solve for a. Okay, what we're going to do for, scroll, we'll lose the triangle, but you can always look back at it after. To solve for b, okay, remember b was, I'll draw the triangle here. Boom, 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 kind of look like this, right? B was right here, A was right here, H was here, X we just solved for 1.53, and that was 10, right? So now we're solving for B, and we can use, well, first we need to solve for H, sorry. Once we have X, we can solve for H because we know that this is 70 degrees. So solving for H is going to be helpful because it'll allow us to do Pythagorean Theorem. So H is tan 70 is equal to H over 1.53. So H is equal to 1.53 times tan 70. We end up with 4.2. So now you know H, 4.2. And now you can get B. B squared is equal to H squared plus X squared. So B squared is equal to 4.2 squared plus 1.53 squared. B squared equals 19.98. So B is the square root of that, which works out to 4.47. So that's one of the first things we had to solve for, B, right? That's really what we wanted. And now lastly, we need to solve for A. And again, think about this thing as a massive right angle triangle now. A is the hypotenuse of this big massive right angle triangle. So A squared is equal to H squared plus 10 plus X squared. And we know all those values. H was 4.2 and X was 1.53. So this becomes 11.53 squared. So A squared is equal to 150.58. So A is the root of that. And that simplifies to 12.3. Now, the good news is, well, maybe the bad news, the hard news is there's a lot going on in these questions. You really got to think through. You got to basically pull everything out of your toolbox that you've learned. Factoring, algebra, dropping perpendiculars, finding right angle trig, right? Like there's a ton going on here. The good news is next section, we show you an easier way to do it. And it's not that this type of solving is unnecessary. It's this type of solving really demonstrates a fluidity of your knowledge and also a problem solving process, right? Like you're not necessarily going to memorize or remember everything. So being able to work through these things is just a good skill to have. Here's some information. Figure out what you need to know with the information that you know. You're not always going to know everything. You're not always going to know the easiest way to do something. So if you can work through something with the information that you have at hand, like that's just a life skill. So that's why we do these. So I think this is the last example. And then we will move on to the next section. So here we have triangle ABC, and we got angle A, 50 degrees, side A is 12, and then side C is 8. So let's draw this thing. It's not the best drawing, so I'm going to erase it, and we'll do it again. Okay, so all right, so And it's still not great, but hey, let's just deal with it. I'm going to call that side A. And what do I know? I know that side A is 50 degrees. That means that this is side A and it's 12. And then C is 8. Now 8 is smaller than A. So it wouldn't make sense for this to be 8. That just looks wrong in my drawing. And even though, remember, you got to be careful with your drawing, but I'm going to call this 8. I'm going to say just deal with that. I know it doesn't look that much shorter than 12, but that's because that's how I drew the triangle. Go with the numbers, not necessarily with the drawing, but be aware that obviously the bottom would have been way too big. So now I'm going to label this. This is angle C, obviously, and this is B. So now B, across the way, I'm not sure of, and C, I'm not sure of. And I also don't know the bottom. So let's just drop a perpendicular. And we'll call this chunk on the left X, and we'll call this chunk on the right Y. All right, and then we'll call this the height. Now, for the angle at the top here, angle B, we're going to say, we'll call this theta. And we'll call this alpha. Okay, so the first thing we're going to do is we're going to solve for angle B. But in order to solve for that entirety of angle B, you need to know both what theta and alpha are, and you're going to add them together. So let's look at something we can find. Well, we can find H. This is a pretty regular occurrence. You're going to see that next section. So H is sine of 50 is equal to H over 8. So 8 times sine 50 degrees equals H. H is equal to 6.13. So erase the H here, and I'll put in what we just solved for, 6.13. So now you got the height. Okay, and with that height now, you can solve for some other things. Now, but we can also solve for theta pretty quickly, right? Like, how do we get theta? Well, you have 90 degrees, you have 50 degrees. So theta is going to be 180 minus 50 minus 90. So theta is 40 degrees. Okay. Now that doesn't help us with alpha though, right? We're going to need a way to solve for alpha. And that's why we needed that height. Because with the height, we have an angle, we have an adjacent side, and we have a hypotenuse of a right angle triangle. So we can use cosine. So cosine of alpha is equal to the adjacent side over the hypotenuse. So alpha is equal to the inverse cosine of that ratio. So angle alpha, is equal to 59.3. So now that you know alpha and you know theta, you can combine them together and you can say, all right, well, I know angle B. Angle B is equal to 99.3 degrees. You just add the two of them together. So now you have angle A, you got angle B, so real easy to solve for angle C. Angle C is 180 minus those things, right? So 180 minus 50 is 130 minus 99.3. You're left with 30.7 degrees for angle C. So now we've solved for angle B, we've solved for angle C. The only thing missing from this triangle is X and Y. And the beauty, well, because X and Y gives a side length B, right? Now the beauty is we can use the same thing to solve for both of these. Let's just go cosine. You could use cosine, you could use tangent. Doesn't matter what you use because you have all the sides. You have this side, you have this side, you have this side. I'm going to use cos for both. So for X, we have cos of 50 is equal to adjacent over the hypotenuse 8. So do the calculation there. X comes out at 5.14. And then the other side, using angle C, cos of 30.7 is equal to y over 12. So y comes out at 10.32. In order to get B, we just add those two things together, and you get 15 point, that's a really bad 15. You get 15.46. And you've solved for every side on that triangle. So, I believe That's it. So there's a lot of practice on this page. You might need some of the extra workspace. I suggest you use it, work through these, just get comfortable identifying which pieces of that puzzle are missing. All right, have some fun, and I'll see you next lesson.